this is work in progress. The notion of the workshop, of the workflow, it's an idea. And what we show here, it's our building blocks of those ideas, because we want feedback on those. The tool, the AGMIP tool for global impact assessment of climate change, it's a tool that isn't part of the GeoShare pilot project. It started as a conversation between Joshua Elliott, I saw Cheryl in the back, and myself in May of last year, I think, at the CIMSANS offices, and say, well, AGMIP, the AGMIP Grid Crop Modeling Initiative, and the AGMIP, Jim, if I don't get all the institutionality right, it's just because I started with, I know that there are the ICMIP, that I think it's at the PIK, and then the AGMIP, it's a joint effort that created a massive amount of information by running 7 crop models, not 5, but 7, I believe. Each crop model was run using 5 global climate models. For each one of these GCM, there were 5 representative concentration pathways. On top of that, there were runs with and without irrigation, and with and without CO2. For 12 crops, all these from 1971 to 2009. So a massive effort, many groups. I'll talk about the work where this has been published, very interesting insights. And there were 35,000 grids, rasters, with crop yields from every combination. Carol showed the hierarchy of the directories where this is stored. So Joshua and I spoke, well, wouldn't it be nice to make this more available? That was kind of our conversation. And the problem is that the economic modelers like myself or Juris Baldos, that is going to talk about after me, we don't care about the data at the grid cell level. That's unwieldy for us. That's way too detailed. We end up aggregating it to the country level. Good luck having an economist getting to work with that net CDF format. This is foreign to us, to be frank. And for what I know, it's foreign for many geographers and other people that is closer to the data. The download of the grids is challenging even with good bandwidth. Even if you are at Purdue or one of these great institutions that we work in that have a lot of infrastructure, it's challenging to download this data. Storage is challenging for otherwise very good pieces. I was talking to somebody in one of the groups that was doing this analysis, that her job was to download this data, and they ran out of space in the computer. So the question was how to make the data available to users. Can we channel that large community of crop modelers and climate modelers that are creating great information, and it's a very large group, institutional group, with the 10,000+ people that we have in the GTAB network, for example? How can we make that link to happen? So the solution was this tool on the hub that Carol already showed the graphical user interface. And basically what we do really, it's an R script, R software. So there are 2 parts to it, a download protocol that connects the hub with the globus and downloads the data. And then an R script that is going to aggregate the data in a very simple way. It's going, so you hear, I think I can take the risk to go live, although I'm not going to do download just because these are large grids. They take quite a bit. But here we are on the browser, so here you do your selections, say PD, SAT, HAT-GEM2 ES, RCP AP5, SSP2, CO2, with irrigation for wheat. So what I just did underneath was to create a string that's going to query the Globus Online Archive, and it's going to bring that data over here. And here is where we add some value to this challenge, this technically challenged economies that we want to serve. And it's in the aggregation process, right? So here we can basically browse. I'm going to browse the data. I'm going to use all the data. That is download. It remains in the hub, so there is no redundancy in the action. If somebody wants to download the same data, it's already there. And when we do this, so I'm going just down to that directory structure. So I have here those results. This is where it's coming from the archive. So let's say that I get the data from 2051 to 2060 for maize, yields, open it. Now here, what we have is it's an aggregation scheme that is simply a mapping of coordinates into units that you want to aggregate to. So it's the coordinates of the grid against ISO country codes, if you wish to aggregate to the country level, or AZs, if you want to aggregate against an AZ, or counties, or the world. It's really up to the user. So there is an upload button and a manual, an instruction manual, where a user can create a customized aggregation scheme. And then you may want to, typically we weight these shocks, right? So if we get all the shocks for Venezuela, we don't want an average. We would like some weighted average, or perhaps using production or yield or area. So here we offer some weighting schemes. I'm going to select harvested area of maize. This is just a raster from Navin, incidentally. So this is a pixelated, an XY indication of the area. And then we just run the aggregation. And this is what I'm doing here, running the aggregation. We can go, sorry, here. Again, how I'm doing with time, Paul?
At the moment, you're about 7 minutes.
7? Okay. So what I get at the end of the day, there are some visualization capabilities that I'm not going to show just because it takes a while to render all the maps. So there are, in this case, there were 35 years, so you need to render 35 maps. But you can look at the maps. But more importantly, for us at least, for this group of users, is that you aggregate the data to the country level. So here we went to from that grid of half degree by half degree to, in this case, 1,500 observations. So you have that weighted average. Let's see where we are here. Okay, so let's see if we can download the output file. Okay, it's blocking things and stuff, but really what I wanted to show was that sort of aggregation. This is huge. This may seem trivial to the people that have access to the technologies and to the computers, but for the guy sitting doing some work that wants some shocks, this means quite a bit. I assume, or if I would be sitting in the audience, I would be asking, well, is this a workflow? Not really. This is not a workflow. This would be a building block of a workflow. So when we envision a workflow using this data, we envision that you could start with these shocks, for example, and after me, there is going to be a presentation about the spam in the clouds. And spam is a data fusion protocol that will be discussed. But you can imagine that you can use these shocks combined with data out of a spam to aggregate the shocks. And depending on what spam is doing, you're going to have a larger or a smaller shock at the country level. So it's not trivial. It may not be trivial, the difference between land allocations that we use to weight to our shocks. We could alternatively use Navin shocks. So that's the idea of the workshop. The workflow. And then that goes into an economic model. Juris is going to talk about that. There was a question about, or we have a question, how much of the workflow could be in the hub? We have enabled simulation software such as GAMS and GenPack, where our models run in the hub. So arguably, we could do all this online and have a self-documented workflow where you can enter that workflow at different levels. You can change the aggregation layer of the shocks, you can change the shocks themselves, and you can change the economic model. So that's the idea that we have been evolving over time. You know, when we talk about this, sometimes it sounds like this is easy. It is not. It's not. It needs lots of commitment. So first you need commitment from the data generators to share their data using open source mechanism. That's hurdle number one. Here we were lucky. The AgNIP team has this willingness to share the data, and they have been working with open source mechanisms. Was easy to communicate, not easy to get to the final product, but to start the communication. The user is interested in sharing expertise to enhance use. In this case, it was me. I have invested some time working with this data. So why not write an R script that is going to be, you know, it needs to look better and work better than what it does in my computer, because it's going to be used by people. And you know that when you create software for others, you don't pat yourself in the back and walk away. Like after you publish a journal article, you gotta keep answering emails, and the thing crashes, and it has a bug, and it's a real pain. So you need that commitment. A capable programmer to build a graphical user interface. So we have a very good, how many with time?
About 11.
Oh, okay, I gotta stop at 13, so Yuri's comes. That's why I keep asking. So we have capable programmers that can do Java and build the graphical user interface. And if we add all this time together, you know, from when we started to the time that we have a tool that is beta that can be used by people without crashing every single time that you use it, it's 3 to 4 months of total developing time. So it takes effort, it takes commitment. It's just a building block of that workflow. But we are seeing the results. We are seeing economies that wouldn't otherwise use this wealth of data, using them. We had an incredible large uptake the first 3 months of the tool. We had like 400 queries over that tool. People was like, really? Climate change shocks from global climate models and crop models? I mean, that's very remote to any of us that is not producing the shocks. So this is the idea behind the AgNIP tool, what we have achieved. And the other question that I want to address before I give the floor to Yuri is why the hub? Why all these sophisticated tech environment for something that simple? Well, it's not easy to publish a web tool unless you have a web programmer that is an expert on that, and you have your own domain, and you pay for that annually, and you have all that infrastructure. Some institutions do have that, most don't. So here you have a kind of a place in which anyone can come, open an account, and upload a tool, wrap a graphical user interface around it, and make it public. And from that viewpoint, we think that it gives some economies of scale and scope to building these workflows. So I'm going to stop here.